Okay, so last time we were discussing layer, first layer, physical layer. In physical layer, what we were discussing that it is a shared media or shared medium where we are going to transfer data between multiple devices. So one device another device which can transfer the data in form of voltage, time and frequency, Wi-Fi, radio signal, those things. So those we had discussed last time. Then we discussed that in case of a hub, if it has four devices like that, this is our hub. So if they will send signal at same time, then there might be a collision occur because there is no media access control who will transfer first and second. So these are the problem with the physical layer, like a single wire connected with four devices. And then we have discussed that if device is a layer X, layer 1 or layer 4, then layer 1 will only understand layer 1, but upper layer will be compatible with lower layer also. So layer 4 doesn't need to understand 3, 2, 1, but it will be compatible with all this layer. So this was the discussion earlier which in previous lecture we had done. So today what we can do is, okay, sorry for that, layer 2, that is a data link layer. So we were discussing that anything which will be transmitted over layer 2, this is layer 2 and this is layer 1, whatever will be transmitted, anything will depend on layer 1. Now question is how and why. So this we are going to discuss, but what it means all the data travels on internet. Now another thing, this layer 2 is very important layer because all data which is traveling over internet will depend on layer 2. So if you see this, here we can see this interface, broadcast, multicast, how this will happen that we will see later, but this is our interface that is for layer 2. So how it is going to transfer. Now coming to the point, so basically layer 2 uses frame to transfer the data. Earlier we have seen layer 1. What layer 1 was using? Voltage, wavelength, And similarly here we are using frame for layer 2 to transfer the data over the network. Now there are two things. If you see this, this is MAC address. So when we are transferring the data, so what it is going to do, here we are using two things: frame, second MAC address, that is a unique hardware address. Basically for physical uh, identification this address is used, and it is provided by the companies. So when we talk about layer 2, so we can see it is a combination of MAC address and frame. And what we have seen here, so it is a hexadecimal address, and which is a 48 bit longs, and it is not a software assigned address. This is uniquely attached to the hardware, so basically it will be always with your machine. Now coming to the MAC address, so it is also a combination of two things. This is so there are the two things which are going to make this address, and this is provided by the company. So hope this is clear. Then we can say layer 2 uses layer 1, means layer 2 or Ethernet frame can be transmitted onto a shared physical medium by layer 1. So we will transfer the data in frame, but it will be converted into a physical medium. So it means like whatever frame we are going to send, that will be converted in voltage. So let me show you how. So suppose layer 2, this will give a frame, then this frame will be received by once that is done, then it will be transmitted over a shared medium. Once that is done, then again it will be received by another end. And then it will be again converted to frame. So that is high level overview how this will be transmitted. Now coming to one particular part. So what is this frame here? So frame is a combination of multiple things. So we can say preamble, second will be our destination. Destination defined by MAC address, then source, then our Ethernet frame, then our data payload, then frame, part, flag, other things. So this preamble is what? This will be a 56 bit, and here we can say this is, you can remember, 8 bits. So preamble, what it will do, it is just for, basically we can say, starting, or we can say it will tell to other device that this is a, like suppose you are a postman and you are delivering something, so there will be a front page on that box, receiver address or something, like what is it containing, so it will tell that it is the start of the frame. So that another device can identify it and check it. So this is the first thing which is our about our preamble. Now destination, nothing but our another physical device which is receiving on another end, source from where it is coming, so it is like a delivering a package, and then Ethernet, that is basically what we can say. So here you have understood these two parts. So when we say frame can be sent to other device by putting this MAC address in the destination field, or we can say if we are going to do multicast, or so we can put overlaps so that it can be sent to multiple device by a single one at the one time. Then ET, what it is used, it is basically used from the layer 3, it is a part of layer 3 particularly, but we can say which is a, it is a layer 3 protocol. Where layer 3 is putting data inside it. We will discuss it later. So how it is similar to layer 2 sending data over layer 1, where we are using a physical medium, and it is commonly used to check layer 3 sender protocol like IP. If you want to check more, so like this, I can show you this what so what it is, this is our 5 layer OSI model layer. So network interface name, it is nothing but, see, this is Ethernet begin with EN, wireless begin with WL, and these are the things. Then it is telling the on indicates what is the and then what are the IP4 layer 3 things which is containing, and then it is defining them, how that is defined. So that's all we can identify from it. Now coming to the payload. Payload is nothing but a data frame which carries from source to destination, generally providing by layer 3 attribute defines which. So basically it is kind of a data and whatever IP and details it is carrying, so those coming inside this payload. So these are kind of similar things, like it is Ethernet, that internet network interface, but it is a data frame. So here if we come to this part, this will be called MAC header, and then this will be a payload. So that's how preamble work, and basically now we can see how we are going to transfer the data. So suppose this is our layer 1 and this is our layer 2. Now earlier in layer 1 we have seen that both the devices can send at a basically simultaneously. So due to that they can collide, so because they don't know whoever is sending first, so data can be or signal can be corrupted. So this is the first problem here. So here in layer 2, suppose this is a PC and it have any MAC address like this one, and here is another PC like this one. So what it will do, so suppose this left PC want to send data to right PC, and so what it will do, it will create a Ethernet frame from PC, and then this frame we need to send to the another side. So here what will happen now, this PC had created a frame F1, and this it will want to send it to the layer 2, but before sending, in first step there will be a carrier check. So layer 2 will check if layer 1 is transmitting any signal or any carrier signal so that it can forward the data. So so if there is no signal will be or there is no carrier signal, so then it can send frame here on this interface, and then it will be converted to voltage or we can say frequency. Here there will be another device interface which will receive this signal and it will send it to PC2. Once that right PC will receive that signal, then it will check if it is intended for it, and then it will be converted to the frame. Basically, that frame it will check, and then it will receive that signal. So here there is one things which we have discussed, that is a so basically CSMA is to check carrier signal multiple access so that it can transmit the data. Similarly, if this one want to send the data F2, it will also check carrier signal and then it will be converted to voltage again, and then it will be transferred here, and then again it will be converted back to the frame 1, and then left PC can use it. So that's how we can say that here our CSMA used to work. So that is like that carrier signal multiple access device used to work here. Now there is another point. We have seen that okay, now we know that how to transfer the data, but we have seen in layer 1 what we have seen. This is PC1, this is PC2, and if they are sending the same time simultaneously, it has started, then there will be a collision. But that is called in layer 2 data is sent as encapsulated. So if the same time left machine is transmitting to the right machine and right machine also sending tried to sending at the same time, then there will be a collision if anyone is transmitting. So due to that there will be a collision, but here in layer 2 there is a collision detection. So here what is happening, so whenever one machine is trying to transmit, so if carrier is detected, that signal we have checked, then it can hold that, and then it will hold to transmit, and then once PC1 has transmitted, then PC2 will try to send. So here layer 2 is containing a collision detection. So if there is a jam signal, so once there is a collision detection, so it will send a jam signal. So when we will get a jam signal, at that time all devices, suppose there are multiple devices are sending, so that time like suppose this is our hub, and it has tried to transmit, F1 tried to transmit, and that time somebody has also tried to transmit, so that jam signal will be received, and through that it can be hold. So earlier in hub, suppose we are having a hub here, so they don't understand that like frame or anything, they just repeat the physical activity from one port to all. So what I'm saying, if this is a hub, so what it will do, it will send this data frame to each one, this one also, this one also, this one also, they will just repeat it, any physical activity to all. Suppose this PC1 sends a frame with the destination of the bottom PC, so hub what it will do, in hub case all will receive, this will also receive that F1, this will also receive that F1, this will also receive that F1, and due to that there might be a collision. So what I'm trying to say is, in layer 1 devices they don't understand frame, they just repeat any physical activity from one port to all ports. So if PC1 is trying to send data to a destination of PC2, suppose this is PC2, so what will happen, it hub will repeat this physical activity to all frame, and that time PC3, PC4, all these will receive that data, and that can create a collision here. But in layer 2 what will happen, we can use a switch, so from that switch we can improve that. So hub is a layer 1 device and switch is a layer 2 device. So we will discuss that thing now, because this data link layer is bit bigger one. So here what we have understood, like PC1 is trying to send a frame to the PC2, but other PC like PC3, PC4 will also try to, if they will also receive that signal, but here PC2 is the intended one. So how here in hub case, how this data is transmitted, so this one will try to send, but at the same time it will be through hub, it will be sent to the other one also, PC2, PC3, PC4 all, but it will check, everybody will check that this address or this frame is having what receiver address. So suppose this is you can say a delivery system like courier system. So suppose to and from, so they will check to here simply, and then based on that, if they have their address, they will accept it, otherwise they will reject it. So this will reject it, this will reject it, but this will receive it because this is intended for PC1. So that's how hub was working. But at the same time, if this is also transmitting, this is also transmitting, then there might be a collision. So for that collision we can use switch. So switch is similar to we can use here. And in switch, suppose this is PC1, this is PC2. Now it is trying to send data F1, then it will send a frame here. What will happen? Switch will see, this switch will see that frame 1 arrive, and what will happen? The first time switch do not know which PC is this. So first time it doesn't know which PC it is having. But there is one thing, okay, I have to draw a bigger picture here. So let me check how we can. Okay. Okay, we can take this. We can use this. Nothing to worry. For, okay. We can take these things later. Okay. So switch will be having one table which will be having MAC and port. It is similar to route table. So suppose this is our address here, and then this is our port here. So suppose this port is, then another one second MAC address, and this is then third MAC address, then fourth MAC address. This table will be like that. So here in switch case, this is switch. Now see here, suppose this has tried to send a frame F1. Now what it will do, it will see that frame 1 arrive, but first time switch do not know which PC it need to send to all. But over the time, this switch will learn, because this it is storing that with the time, these frame and port address. So all these will be frame and basically stored here in the MAC this table. So when it sees the frame, and it can interpret that with the source and destination, like where it need to send and from where it is coming. So switch understand frame and MAC address, and they basically maintaining this MAC address table, which is basically receiving those frame and ports, so that it can learn which devices are connected, and uh, basically over the time they will populate these things. Now second point, if this frame F1 is transmitted, it will be forwarded to one of the specific port. So here like H0 or this port will be, it need to be forwarded to this specific port. So here port will be in the important role here. Suppose now what will happen, any frame which will be like this PC2 is there, so it will check like switch, basically what we have understood, it will store and forward, they don't repeat blindly, but they will check for the valid frame and then they will forward. So second time it will check what is the port number or what is the destination, and through that it will forward that data to the basically intended one. So what I am trying to say here is switch, store and forward, but they don't repeat blindly like hubs. It means only the intended or only those isolated valid frame are forwarded. And then collisions, जो basically those collisions, if there is any collision or anything that can be isolated, they are just forwarding only valid frame. And collision can be isolated here. So after that what it will do then, suppose another PC, next time another PC like PC3 is trying to send, so switch is having this MAC address table, and this time they know that H0 and MAC address source and destination is for which port, and here they will know which port it need to forward. So this time they know, they will uh, do the work faster and they will send it quickly. So that is about the switch, basically how it is going to send and how it is going to avoid collision. So every time that switch will check which port it need to forward. So that is the basically we can say intelligence of the switch, that it don't blindly forward to all. So it will be for, it will, if there is mention all f, that time like that time it will forward to all, or that is kind of a broadcasting. So there are two things we have understood, that switch, it forward only valid frame, then on each port it has a separate collision domain. So that those collision can be isolated and only valid frame can be forward. So and we have seen hub were repeated blindly, but they are not forwarding that data blindly. They are first storing here and then forwarding. That's how they are doing, and they are only forwarding valid frame. So collision are already isolated, and wherever which port, like suppose on this port it is happening, then that collision will be isolated, and if this is transmitting, then that will be transmitted. If this is transmitting, that is transmitted. So that's how it will happen. So that's all about switch. So basically, what we can say about layer 2. Layer 2 contains, we have seen that, okay, MAC address table. So through that they are storing the data. So what we are doing, device to device communication. Like earlier on layer 1, there was a shared medium. But here we have layer 2, we have identifiable devices. So device to device communication can happen here. Then there is a media controlled access. We have seen that signal check, CSMA and other things. So basically device can share access to physical media, but they can avoid that crosstalk. So that shared access, like layer 1 they can access, but they can avoid crosstalk, because it will check which device is sending the signal. If there is a jam signal, all the device will hold back, and once that is done, then another will device will try to transmit. Then there is a CD, collision detection. Then there is a unicast, like one to one communication. Then there is a broadcast, like all F are mentioned there, so we can transmit signal to all the devices. So that's all about data link layer. There are lot of things which might be remaining, but I try to cover most of the things in the short way. Thank you.